I'll promise I'll do my best to keep it short and exciting. And in that note, one massive caveat, this talk is about complexity. I'm showing our whole landscape in terms of deletion. And of course, with less than 20 minutes, I cannot go into excruciating detail. You should be thankful for that. It would be very, very boring. But that also means that for any slide talking about a problem space or solution space, there is asterisks in there. There's always an edge case. There is always an extra consideration. If any of those pique your interest, please let me know. Ask me during QA. It will be a pleasure to deep dive on anything of interest to you. So I'm assuming here that not everybody knows what Stripe is. So real quick, we sell financial infrastructure to the internet overall. And to give you a sense of scale, last year, we crossed the boundary of processing over $1 trillion in payments. That corresponds to roughly 1% of the internet's GDP. This is not me trying to do any sort of advertising. This is me showing you scale of Stripe, right? So how do we do deletion at such a massive scale? Well, first, we have to understand motivation and balancing factors here. Our major motivation is, first, fair use of data. We want to do right by our customers. And of course, there's all sorts of fun compliance stuff that we have to observe. And this, of course, there are opposing powers, right? First one, typical cultural element, data is the new oil. Oh my God, I can do so much with that data. And we usually have to go and say, no. We're going to talk about that in a few minutes. But also, there's concerns about, hey, you're deleting data. Can't my availability suffer? Can't I have reliability issues? And because Stripe plays so much in the financial space, there's a third, even more massive power at play here, which is called regulatory retention, right? We are processing payments. That data is regulated by anti-money laundering laws. It's also regulated by financial regulations, by tax, so on and so forth. So we have to find this balance of deleting data as soon as we can, but not sooner than our regulations require us to. Because of this, actually, an account lifecycle has more stages than this, but from a privacy perspective, those are the ones that really matter. An account goes from an active state until they say, hey, I'm done. I'm happy to close my account, which means it goes into a closed state. And for many, many kinds of data, we cannot just delete all the data. We have to hold it for a certain amount of time. But during that time, just a subset of our use cases can actually touch that data. This is a very big conversation about authorization. I'll skip that detail. Today is about deletion. But after a certain amount of time passes, we have no more reason to hold that data. And when that happens, we call it expired data, and we kill it. So these are the 2 points of interest to us. First one, when an account closes, we have the first trigger and opportunity to delete some of the data. And when it finally expires, we now can delete all of it. I'll spare you the details, end of day, but we're talking end-to-end Stripe, right? So we have this online side of the world, which you may hear me calling mainland. That's why I put it there. It's composed of this massive Ruby Mongo monolith that has code that can be up to 15 years old, and a bunch of new services that can be written in Ruby, Java, on top of Mongo or Aurora, all sorts of fun stuff. And of course, many different ways to represent accounts, many different ways to determine affiliation across the board. So yeah, you can picture a very complex model that this thing does not do justice. And the offline world, right, when data hits our data lake, we're talking about all sorts of data structures. We do have event streams. We have your typical batch process data set. We have pretty much everything you can imagine under the sun, because that's a data lake, and the rules there are no hard rules really when it comes to data composition and reuse. And of course, this powers some of our product features, our overall reporting, and corporate strategy. So, summary already. First one, there's target data everywhere. Because it's financial data, we cannot just isolate it to one single place. That data is present in many, many systems. And that data, when I say it, it's anything we can call personal data, data pertaining to a customer. Because of that, it's a very large volume of data to evaluate, both by count and volume itself. We're talking about hundreds of thousands of data sets and hundreds of petabytes of data. Because of this as well, and as you may have glimpsed from the previous slide, there is massive architectural sprawl. We're talking about different platforms, different languages that we have to tackle, different capabilities that are present, different ways to represent the data that we should kill. The good news on our end is that since Stripe grows very fast and since it has good retention, the amount of data that we actually have to delete, it's pretty large, but by comparison to our data growth, it's small. So it allows to keep things contained. That reality led us to a few very big, early takes. The first one, which is a privilege that we have, our business is in selling financial service to customers. We have no business selling customer data. So we had this very good advantage, which is by the time data expires, it goes away. It doesn't matter where it is. Sometimes people say, what if I kept this piece of data? And our answer is, no, we kill it. So this hard line has allowed us to have this binary decision that simplifies a lot of the conversations we have to have. Because it's so much data, so many data sets, so many permutations, it's impossible to figure out impact of deletion across the board. Because of this, we went with exploration. We deleted a bit of data, learned about it, rinse and repeat. We're going to see a bit of that in a minute. And of course, because of this, there's no silver bullet, not one single solution. We had to implement many solutions to those many different architectural permutations of interest. And all of them tend to have this sort of paved road, dirt road, and off-road solution approach in which we do and say, hey, we have a paved road for the Pareto. If you're well-behaved and you're doing this, you are within the 80 to 90% of people who are doing this thing that we can find a solution for you, good. If you are on the other 10-ish%, there's this thing that you can do with a little bit of effort. And if you're on the 1 to 2%, yes, you are in for a world of hurt because there is no single point solution that will cater to everyone. So what are the big patterns and learnings that we took out of this whole big exercise? First, the challenge to identify data, right? We have to know for all those thousands of data sets, which ones contain data that should be deleted, and when the time comes that an account expires, to identify that account within those data sets. So I'm talking here mostly about the online world, but the first thing that we did is we came up with this beautiful model of an affiliation graph. We identify the collections that could identify customers, and then their relationship to other collections. So this is the beautiful original model. Things turned out to be, all sorts of cycles, all sorts of gaps. This turned into a nightmare. You can see it's called V0. It never saw the light of the day because the semantics for graph traversal for both deleting data and finding what data to hide were just far too complex. And the motivation here was to simplify things and not be intrusive about design. Guess what it was? We had to ask people all sorts of questions. OK, but how does this piece of data here relates to that piece? It ended up being a massive tax on engineering overall. So, and this already did not work on the online world. As we copied data into the lake, we would have to redo that again. So we dropped this and we went with a denormalized approach. So if any piece of data is affiliated to a customer, it has to have a column that identifies that data. Does that carry across those hundreds of thousands of data sets? No, but for the vast majority, that is true. And thanks to that, we can easily look into a given data set, be it online or offline, and identify which ones have to be deleted when the time comes. There's edge cases. We talk about polymorphism, which is, hey, this thing here can relate to this kind of customer or that kind of customer, and the rules are different. Polyaffiliation, this thing here actually relates to these many customers, or people coming up with all sorts of crazy affiliation things. We stopped talking about those terms, and we talk about complex affiliation. If you have one of those, guess what? Your solution is not a paved road. We will not hold your hand throughout the process. You now have to give us a mapping function. We tell you, hey, these are the IDs of the accounts I have to delete, and you give us a list of documents that we should be deleting. That's a pattern that we have been using across the board with a reasonable degree of success. Second big pattern, orchestration. So this is what we did in the online world. Our first iteration was mostly successful for this. We built this massive inventory for that Ruby monolith that I talked about. So we have this big collection that says each and every document that has to be deleted and when. So the beauty of this model is that results are very predictable. It fits most of the monolith quite well, but it comes with a few downsides. First, high cost. complexity and maintenance for this because we're keeping track of millions and millions, billions actually, of documents. It's intrusive in design. It means we have to go and poke all those collections, and it's not very SOA friendly. And this, like anything related to deletion, caused a lot of FUD, fear, uncertainty, and doubt. And here I have to take a detour. How do we defud deletion? So there are two major objections that you see when you're talking about deletion. The first one is the what-if scenario, right? I call that walking people through the 7 stages of grief regarding data loss, right? What if I need this? And the answer is usually, We have cowardly refused to engage in hypotheticals, and I highly recommend anyone who has that option to do the same, right? If that's all you have to provide me, okay, it's an opinion, not a data point, I'm moving forward. Now, people would come up with some very, interesting thing, which is, what if this breaks? And that's a valid, legit case, and for this we had to prepare. So I'll spare you all the details, but I'll talk about the most fundamental thing that we do for safe deletion. Remember that closed account state that I talked about before? That is an authorization step. And thanks to that, which is a very complex undertaking, we can also put this same sort of control in expired data. So before we go in and delete data, we lock it down. Nobody has access to that data for a couple of days. And if anything breaks, anybody screams, we can just revert that lock and people can have access to that again. That has happened 0 times. Then we move the data to a backup, to a vault. Those are protected collections that are kept under lock and key. We do not have interactive access to that, just programmatic access to copy data there. And we kill it, right? It has a retention limit. And then finally we remove it. This simple pattern has saved us a lot of pain, and has been executed a couple of times, but we're going to go there. So what are the results of that previous thing? Literally many billions of documents deleted, 0 wrongful deletions, 0 high severity incidents, right? Which has empowered us to do a lot more deletion across other places. There are downsides to that approach. So for the new SOA stuff, we do orchestration with SOA. So we have this workflow that pretty much reaches out to service. And this is where we adopted a batteries included but optional solution, but replaceable solution, in which every new service is born with a deletion endpoint. You don't like it, provided by us. You don't like it? Sure. You can override it as a service owner, create your own deletion, hook into things, we'll verify it works, and you're good to go. So it caters to both, the paved road scenario in which, yes, this just works for me, to all the sorts of dirt road and even off-road cases in which people have to do some very special handling when it comes to deletion. So overall, a big plus. Controlling load shedding on those deletion operations is a lot more complex undertaking. We can go there in details if you're interested later on, but I'll skip. One more big pattern, propagation. In an ideal world, this is what deletion would look like for us. Because we're deleting data in the online world, and it's basically the source for everything that goes into the lake, we could say, hey, we're deleting at the source, therefore the deletion propagates to the offline world, right? End of story. You would have a few minutes back to you. Nope, not really. Because there are limitations to propagation, at least there were to us. First, some folks drank the immutable Kool-Aid and said, we won't ever delete data. We just append things, and we have to have some very difficult conversations with those teams. There are also teams that say, I know those deletion events are coming up. I just gladly ignore them, which also leads to some interesting conversations. Those are small in percentage in our case. The case that is the biggest concern for us is old snapshots. People may generate, for example, batch datasets by batch jobs once a week, and they may keep those old versions of the datasets. Sometimes they have reasons for that. We have financial regulation that requires us to hold that for a long time. But sometimes people want to hold that data forever, those old copies forever, and then, of course, those old copies will contain expired data. So how did we tackle this? First, the easy, good, bang for buck thing is we went on to every single team and said, hey, instead of holding data forever, if you hold this data for 1 month, you are saving the company this much amount of money. And we kind of made a dashboard and incentivized people to do that. And by virtue of doing that, we solved Between retention limits and age limits, so I'll talk about that right now, we solve for more than 80% of our problems in the lake. What is age limit? It's a variation on retention. If you have events that are day old, this transaction happened today, and for example, that transaction will be held for 10 years, I know that that given record that in a log can be kept for up to 10 years and still be compliant. So when we have guarantees like that, we have age limit controls that allow us to have a more lenient retention. If none of those work, and even easier, many people do just sanitize logs that have no customer data whatsoever. You're good to go away. And if none of those three things works, then that's when we get into point deletion. That's when we orchestrate data deletion in our offline world. Why do we want to avoid that so much? Easy, cost. We're less than 5 minutes, so thank you.